am Kaushik and I am the leader of my team of Optimus. We are being prepared, we are preparing for the event called IRC, that International Robotics Challenge at IIT Bombay. We are well preparing for it, and we have to take the event is, the competition is that the main thing is the synchronization between your autonomous and manual robot. The autonomous is the grid follower that will follow the white line on black surface. So we have prepared for our work in progress is in progress. As you can see here, this is our autonomous robot that we have unplugged few wires. As a microcontroller, we are using the Arduino Leonardo. That is the microcontroller, and let me see. For the sensors, we are using the digital one, that is single sensor, this one. We have taken out all the LEDs of these sensors and put those LEDs on the surface. As you can see, here is the surface. These are the LEDs. These two LEDs will allow this robot to follow the line, and the next two LEDs at the end of the body will allow to count the number of intersections. These LEDs will count the number of intersections on the grid. And the motor is of 100 RPM. That's yellow one motor, as you can see here. We have put the normal wheel, and the body we have made by the wood, that's mica wood. And for the Arduino, we have used the motor driver. That motor driver is L293D. We have made this PCB that is mounted on the Arduino. This the motor driver is L293D. Rest of the pins on the Arduino, and few pins. These pins are for the sensor, and these two next pins are for the motor. And as you can see here, the rest of the pins, these are for the servo motor that will be used in the arm and braking mechanism. The competition is that the grid follower should follow the grid and pick up this box, that is 10 centimeter cubic box. So we have to make an arm by a servo motor, and right now that work is in progress. We have just built a grid follower right now. For here, and we'll mount the servo motor, and by that servo motor we'll have an arm. We'll have a gripping mechanism like this that will grip the box and hold it upward. While for detecting the box, we will implement a digital infrared sensor just in front of this robot like this. As you can see here in the middle position, and whenever the box will come in front of it, this sensor will sense it as an obstacle and will program it. When this sensor turns on, the arm will go down and grab this box and pick it up. So that's what the programming is. That's what we have implemented. Right now, our work in progress, we have built a grid follower. We have built a line follower from this Arduino. This is how the chip will be mounted on the Arduino, and these wires. These are the motor wires, and this one is for the sensors, taking all the output pins from the sensor, and also the two pins serves as ground and VCC output. Okay, so this is our autonomous robot, and the body is fully completed. The microcontroller is Arduino, the motor driver is L293D. We have built a PCB for the motor driver to mount it on the Arduino, so it's a little bit compact design, so I like it. And the further thing that what we are doing, trying to do, that right now we are using the digital sensor, all that on the ground base surface of the robot, but as we are using Arduino, so we can also use the analog sensors. From the market, we have bought two sensors. The first one is the analog one. You can see here is the array of sensors. These are the analogs. We will use 5 sensors. 2 sensors will detect the line. 2 sensors will allow it to follow the line, white line, and the rest of the end 2 sensors, these will count the number of intersections, used as a counter in the programming. So we have the analog sensor, and we have also the digital one. These are the 5 sensors, but digital will work on analog sensor. Right now, for this digital, if we talk about digital, we have already implemented the digital on the body of our autonomous robot. So using these sensors is quite, I don't think that will be quite good. So the plus point in our robot is that we are using analog sensors. Whether the value decreases, whether the line is not more perfect or it is not white, not perfect black, our this analog sensor will work in any condition. So the first point in our autonomous robot is that we are using analog sensor for following the grid and for following that grid. We are practicing right now. We have made the cube and we are we have built the arena. You can see here is the arena. We have made a short arena, small scale arena, and right now we are practicing on the white surface. The robot will follow the black line, but the competition is that we have to follow white line on black surface. So right now we are practicing on this. Finally, we will change this surface to the black and line to the white line. And as you can see here, this is our autonomous robot.
And what?
I show you the working in the previous video. This is the manual robot. Sorry. We have shown you the working in the previous video. So I'll show you right now what is in it. What are the things implemented in it. As you can see here, it's quite heavy, but it's good for the competition. At least it has the arms and the grippers for holding the autonomous robot and for holding the autonomous robot and the cube that will be placed. This is the cube, and we have to pick up this cube while autonomous will bring this cube to the manual. Manual will pick it up and follow it to the transfer zone. So this is the mechanism we are using here. Four motors. We are using here 4 motors for the drive, and we have used the chain mechanism tank. Here, for lifting, we are using a motor where the transmission is provided by the spur and wound gears, as you can see here. And for gripping, we are again using the worm and gear mechanism. It's the plastic geared motor. The good thing is that we are using belts on our robot. The belt is manually built, it's homemade, and it gives a perfect grip on any surface. Although we don't require that, but